Dear student, welcome to you e-learning classes managed by Modern English School, Nevada. Dear students, myself Sujay Kumar, your mathematics teacher, Modern English School, New Area, Nevada. Today I discuss the new chapters, the part of the real number, that is exercise 1B of example. So let's see here how we can solve some problems related to HCF and LCM and composite number and prime number of exercise 1B, and first you solve example of it. So see here, your first question of example is, so that each of the following is a composite number. Dear student, first what is composite number and what is prime number? A number which has exactly two factors, one and itself, that is called prime number, and a number which has more than two factors, that is called composite. Similarly, first you see that is 1, it has only one factor. 2, it is 1 and 2 factor. 3, 1 and 3 factor. 4, 1, 2 and 4. 5, 1, 5, 6, 1, 2, 3, 6. So here 1 it has only one factor, 2 it has only two factors, exactly two factors, 3 exactly two factors, 5 exactly two factors. Then this is called prime, prime and prime. And composite, a number which has more than two factors. So 4 is composite, 6 is composite, because 4 has 3 factors and 6 has 4 factors. It is more than 2 factors, then it is composite. And 1 is neither prime nor composite. 1 is neither prime nor composite. So your question is that you find so that it is composite. Then it is clear, you have to prove it has more than 2 factors. So here is sign plus. So you take 13 as a common. Then you write here 5 into 11 and plus 1. Now it is 13. Here is 55 and plus 1. That is 13 into 56. And sum is here, that is 56 into 13. 6 3 are 18. 5 3 are 15. 1 16. And 6 and it is 5. Here is 8 2 7. That is 7 to 8. Dear student, to find out, it is 7 to 8. When you solve, you get 7 to 8. And it is first, it is the factor 13, other 56, other is 728, and last is 1. So there are 4 factors given, because a product of 2 numbers, then you get a third number. So it is factor, 728 factor, 1 factor, and so many other also factor. But you have only required more than 2 factors. So you write it is 728, and you write it has more than 2 factors, more than 2 factors. So it is composite. So it is composite number. That's. Now second question, so that any number of the form 4 to the power n, where n belongs to capital N, can never end with the digit 0. First to understand the question, what is question asked to you. Here some symbol, that is one symbol is n belongs to n. That means this power of 4 is 1, 2, 3, 4, 5, 6, etc. This is the n and it belongs to n. This is n denotes natural number and this n denotes power of the 4. So your question is, the power of 4 is always natural number. This is to belongs to, means member of the natural number. Otherwise नेचुरल नंबर का एक सदस्य, n is the member of the natural number. That means the power of 4 is only natural number, any one from the natural number, that is 1, 2, 3, 4, 5, 6, 10, 11, anything. So first we understand what is this and what is this. Here is 4 to the power n, and here n belongs to n, where n is natural number. And next, your question is, it is never end with 0. That means when you write 4 to the power 5, that is 4 into 4 into 4 into 4 into 4. Then it is 4 4 is 16, 4 is 256, 4 is 10 24, and 10 24 into 4 is 4 4 is 16, 4 2 is 8 1 9, and 4 0 is and 4 4096. Any number, when you multiply 4 into 4, you get 16. Your question is, any times you multiply 4, that is 5 times, 6 times, 7 times, 8 times, any, and you never get 0 of end of that number. Why? Give reason of it. So now solve questions. How can solve? You write 4 to the power n, we express 2 into 2 power n, that is 2 to the power n into 2 to the power n. According to the fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? Any composite number can express in the product of primes, and that is unique. Any composite number can express the product of prime, and that is unique. That means 20 is composite number, and we can write 2 into 2 into 5. That means the all number of these are prime, and it is expressed in the product of prime, and it is unique. That means no any number other than this. Any when factorize 20, then only get 2 to 5. So you write 2 to the power n into 2 to the power n according to fundamental theorem of arithmetic. It is unique. It is unique. And we also know that any number comes to end with 0 when its factor are 2 and 5. Here 2 is present, but 5 is not present. So it cannot end with 0. So it cannot end with 0. What is the matter? Any number comes to end with 0. Suppose your 0 is 20, 30, 40, 60, etc. That means 2 into 2 into 5, 30, 2 into 3 into 5, 40, 2 into 2 into 2 into 5, 60, 2 into 2 into 3 into 5. That means you find out, here suppose 100. Then you write 2 into 2 into 5 into 5. Then you find out any number, here is 0, here is 0, here is 0, here is 0. It is only 0 when its factor are 2 and 5, 2 and 5, 2 and 5, 2 and 5, 2 and 5. Then it comes to 0. Otherwise not possible. Any number you write 100, 1000, 10,000, 20, 40, 60, 120, 140, anything. any number you write, then you get the factor of this number is compulsory, that the factor of that number are 2 and also 5. But when you express 4 to the power n as 2 into 2 to the power n, then your factor is only 2. Here 5 is not present, and it is also according to fundamental theorem of arithmetic, it is unique. That means no any number other than 2 when you factorize the 4. But we know that any number comes to end with 0 only when its factor is 2 and 5. Here 2 is present, but 5 is not present, so we cannot express the number that's end with 0. That's it. Now see question number 4, that is find HCF and LCM of 126 and 156 using prime factorization. Your question is find HCF by prime factorization method and hence find LCM. Dear students, before this you find the HCF by Euclid divisions methods. Now you find out the HCF by prime factorization method. This method already you have read in previous classes, class 6 and 7. So see here, first your question is 126 and 156. So first we find prime factorization, that is 126 divided by 2, 63, divided by 3, 21, divided by 3, 7. You find out that all number 2, 3, 3 and 7 all are prime, and it is the prime factor of 126, and this method is called prime factorization. Here is 156 divided by 2, you get 78. Here divided by 2, you get 39. Here divided by 3, you get 30. Then 156, the prime factor is 2 into 2 into 3 into 30. Now here is 126, I write 2 into 3 into 3 into 7. From here, 2 into 3 into 3 into 7. Here 156, I write 2 into 2 into 3 into 13. 2 into 2 into 3 into 13. First find HCF. It is very simple. What number common between them? If 2 number, then what is the common factor between them? Other you have 3 number or 4 number, then what is common among them? So first you find what is common. Here you find it is 2, here you find it is 3. So only 2 factors are common between them, 126 and 156, that is 2 and 3, hence 2 into 3, that is 6. And how to find LCM? So first you write this prime factor as in the form of exponents. So here is 2, 3, 3, 7. Then you write 2 into 3 square into 7. Here write 2 into 2, 3 into 13. That is 2 square into 3 into 13. You find out here that here is 3 to the power 2 and here is 3 to the power n. Here is 2 to the power 1. Here is 2 to the power 2. Then maximum power, and that number you write in LCM. So here is 2 to the power 1 and here is 2 to the power 2. So you write 2 to the power 2. Here is 3 to the power 2. Here is 3 to the power 1. So you write 3 to the power 2. 7 is not present here, so you write 7. 13 is not present, so you write 13. Every factor you write here. But that exponent is greater, then write, then a smaller exponent don't write. Then 2 square into 3 square into 7 into 30, then 4 into 9 into 7 into 30, and you get 3, 2, 7, 6. It is the LCM and it is the HCF. So this method is prime factorization method. So dear student, try 2 or 3 questions with the help of example. You find out HCF and LCM by prime factorization method. Now see question number 6. The HCF of 2 numbers is 23 and their LCM is 1449. If one of the number is 161, then find the other number. It is a formula in previous classes related to HCF and LCM, that is first number into second number is equal to HCF into LCM. First number into second number is equal to HCF into LCM. So first number is 161. One number is 161. I write here. You have to find second number. So I write second number. So 161 into second number is equal to 23. That is HCF, and LCM, that is 1449. Then what is the second number? This is 161. Divide this number. So 23, 7 ja, and 7 2 ja, 0 ja, 7. Then you get 207. It is the second number when HCF and LCM is given and one number is given. That's all. Now example 8, that is find the simplest form of 148 by 185. Dear student, any number write the simplest form. If you know that number, what is the common divisible by of that number? That means 148 and 185 are divisible by same number, and that number is what? It is very difficult problem without finding HCF. So this type your question, find the simplest form. So first you find, suppose your question is 20 and 30, then it is very simple, because you know it is divided by 5 4 times and 5 6 times, it is divided 2 times 3, that is 2 by 3. But here is 148, here is 185. It is divided by 5, but it is not. It is divided by 2, but it is not. So this type problem, you first find the HCF of these two numbers. So first find HCF of 148 and 185. By division method, it is very simple, prior to division. So 148 divides 1 times, that is 37, and 37 4 times 148. So 37 is the HCF of these two. And that means HCF is the highest common factor. That means this 37 exactly divide 148 and 185. So you divide 148 by 37 and 185 by 37. Then it is 4 times and it is 5 times. Then your solution is 4 by 5, and that is your answer. It is the simplest form. Remaining questions try to solve, and next day I solve the remaining problem of these examples. So okay.